Okay, so today we are going to be going through the exam review number 2. You've already done number 1. We will have one more, but today we're going to just kind of rock through exam review number 2 and look at the different things that you might see on your semester exam coming up. So these are classifying each numbers. We know that we have all the different ones. The smallest is going to be those natural numbers, followed by whole numbers, integers, rational numbers, and then on the opposite side of rational, we have those irrational numbers. However, everything is a real number. So when it comes to what I'm asking you for on each of these, I want the smallest classification that these numbers could fit into. So if I look at like negative 25, I know that negative 25 is considered an integer, right? Because integers are all the natural numbers plus that whole number and their negatives. Therefore, negative 25 is an integer. The smallest classification that 0 can be, I know, is going to be a whole number. 56 is just one of those natural numbers. Then we have the square root of 27. Now this one you might have to punch into the calculator, but we know that anything that is not a perfect square would be considered an irrational number. Next I have 2/3, and 2/3 is the same as like 0.333. So it's definitely not an integer. It's got a decimal involved in it, so it is simply going to be a rational number. And then lastly, we have negative 3 1/5, which is the same as negative 3.2, which again is considered a rational number. So now we're going to look at these bottom numbers, and I'm just going to kind of do a little loop this way to mark those. Excuse me. So 2.916 ... that tells me that that number continues to go. It's not going to stop. It's going to keep going, never end, not repeating a pattern, which makes this one an irrational number. Next, we have 1.3333333. That one is repeating a pattern. So that 33 is repeating, which makes that rational. Next, I have the square root of 81. I know is a perfect square. Square root of 81 is the same as 9. Therefore, that one is considered a natural number. Next, we have pi, and we have talked about the fact that pi is the best example of an irrational number. Never ends, never repeats. Next, we have negative square root of 64. That just means we're taking the square root of 64, we're getting 8, putting a negative in front of it, which would make it negative 8. Therefore, that's going to be considered an integer. And then lastly, we have 1.25, which is rational. And I'm going off my paper a little bit, but that's okay. All right, so we've classified those numbers. Now let's move on. On number 2, this says to find the side length of each square with the area given. Round to the nearest tenth. That means 1 decimal place. Now remember, if I need to find the side length, when we're talking area, remember to find the area of a square, it's length times width, which means one side times another side. So if I want to find one of the side lengths, I actually need to do the square root of that area. So in this case, I have 200. I would do the square root of 200. Now I have my calculator here, so I'm just going to pull it over, and I am looking at doing the square root of 200, and I get 14.14, so rounding that would simply be 14.1, and that is inches. Next I have 121, so that's the square root of 121. So I know that's a perfect square. That's just going to be 11. Whoops, that's centimeters on that one. And then lastly, I have 26, so that would be the square root of 26. Let me just pull that over. So the square root of 26 on this is 5.099, which rounded to the nearest tenth is going to be 5.1. All right, so that is how we find the side length of a square when we know the area. Moving on, now we have to list numbers in order from greatest to least. This seems to be the biggest struggle that I've seen with you guys this year has been ordering numbers. Remember, when we order these numbers, we have to convert them to decimal form. We can't put them in order until they're in decimal form. But remember, it tells us to write them in their original form when we go to line them up down on the bottom here. So let's go ahead and first start by converting our numbers into decimal form, and then I'm going to line those up and go from there. So I have 2 times the square root of 5. So I'm just going to, again, do the square root of 5, and then multiply that by 2, and that gives me 4.47. So 4.47. I'm just going to write them over here. And then I have negative 0.17 already in form for me. Next, I have negative 1/7. Excuse me. So that's going to be negative 1 divided by 7, because I know a fraction is just a division problem. And that's negative 0.14. Negative 0.14. And lastly, I have 2 pi. Well, pi is 3.14, so 2 pi is 6.28. All right, so now I can write these in order from greatest to least. I see that my biggest number here is positive 6. So my biggest number is going to be 2 pi. So I've used that one. My next biggest is going to be the only positive number I have left, which is this 4.47. So that's 2 square root of 5. So I've used that one. Next, we're starting to go backwards down that number line. So I have to actually think kind of differently when I'm going backwards on the number line. So in that case, actually negative 0.014 is my bigger number, which is that negative 1/7. And that only leaves me with negative 0.17 to fill in the blank. All right, let's flip our page over. All right, here we have a question about angles, which we pretty much just completed. If angle 5 measures 125 degrees, what is the measurement of angle 1? So we're asking for what is this measurement right here? Well, I see that these are corresponding angles, which means they are congruent. Therefore, if angle 5 is 125 degrees, then angle 1 is also 125 degrees. Number 5, Andy makes $268 for 9 hours of work. If the amount of money varies directly with the number of hours worked, how much will Andy make if he works 25 hours? This one we're going to set up using that proportions. Like we're going to use proportions here because I know that y varies directly to x, and then this tells me that money varies directly to hours, right? So I know he's making $268 for every 9 hours. So how much will he make, what is y, when he works 25 hours? Well, again, to set up that proportion, you're just setting them equal to each other, and then we're going to solve by cross multiplying. So I would have 9y equals, let me get my calculator, 268 times 25. So that gave me 6,700. And my final step here is just to divide by 9 on both sides. Divide by 9, and I get that y equals 744.44. So therefore, for 25 hours, he's going to make $744.44. All right. What is the solution to the simultaneous equations? Guys, anytime you're looking at these and you have two lines and they cross, the solution is simply where the two lines meet. So the solution here, we're just going to go through and look at what is this point. Well, this is back 1, 2. So back 2, down 2. So negative 2 would be the solution to both of these equations. That just means that this point would work in each of these equations of these two lines. Number 7. A proportional relationship can be written in the form, now remember it's talking proportional relationship, so in those cases it is simply y equals kx. We have to think back to before we started slope-intercept form here to think about that. Number 8, a youth group planted, labeled, and recorded the height of two different types of trees. Tree A measured 12 inches, okay, so it's starting at 12 inches, and grows as a rate, it grows, that means it gets bigger, at a rate of 3 inches per year. Oh, look at that per, that's one of those keywords. Tree B measured 16 inches and grows a rate of 2.5 inches per year. For what number of years will B be taller than A? So what it's asking is, when will B be greater than A? And all it's saying is, hey, write the inequality for what this is. So I'm going to do this. For B, it was 16 inches, and we are adding 2.5 per year. So that's what gets my X. And when is that going to be greater than tree A, which starts at 12 and grows or adds 3 inches per year? So that is your answer there. Now, again, we could always flip this around. If you flip it, though, remember, if you flip A and B, you have to flip the direction of your sign. So B is greater than A is the same thing as A is less than B. Next page. All right, so just like what we looked at a few minutes ago, we did a solution to the simultaneous equation. So again, all we're looking at is, where do the two lines cross? At this point, it is right here, and that is over 3, up 4. So our answer would be 3, 4. And you do want to put that as an ordered pair. So now we're going to look at number 10. All this is asking us to do is solve for X. This is an equation with variables on both sides, so kind of like a 3-step equation we've talked about. At this point, we all know how to do it because we have been using this a lot. So our goal is to get all of our X's on one side, get our constants on the other side, and then just simply solve for X. So I'm going to start with moving this 3X, this negative 3X, by adding 3X to both sides. And notice I always line up my X's. Now when I do that, I'm left with 13X minus 23 equals 29. And in this case, I have a 2-step equation. Now, I've been doing this since 7th grade, so I know how to do this. I just simply need to get that negative 23 away. Because remember, if I cover up, I'm trying to get X by itself. And the only thing that's stopping me right now from really getting this 13X by itself is that negative 23. So to move that to the other side, I'm going to do plus 23. And whatever I do to one side, I have to do to the other side. And that leaves me with 13X equals, and that is 52. And we all know our last and final step is to divide, and we're going to divide both sides by 13, and therefore we get X equals, I think that's 4. I'm going to double check just to make sure. 52 divided by 13, oops, 52 divided by 13, it is 4. Good. I can math. All right, so X would equal 4. I can check my work by plugging 4 back in to the X's and solving, and if I get the same number on both sides, then I did it right. Number 11, which point on the number line is closest to the value of the square root of 152? Guys, you have a calculator. Let's just use it. Let's punch in square root of 152. I get 12.3. I'm going to write that down right here, 12.3. So where is 12.3 on my number line? Oh, right here at J. All right, the graph of a linear function is shown on the coordinate grid. The question here, what is the y-intercept? Guys, this is not asking you to find slope. It's not asking you for anything but to tell them, where is the y-intercept? Where does my line cross the y-axis? And in this case, it is -5. Next problem, what value of X makes this equation true? This is another one of those equations with variables on both sides. I'm just going to work my way through it and solve for X. So I'm going to start by moving this 0.1x to the other side by subtracting it. Okay, once I've done that, I'm left with that -5, so I'm going to do +5. Which leaves me with 0.5x equals 12. And then if I divide by 0.5, I get x equals 24. Now be very careful here, guys, because many of you would divide 12 by 5. But remember, it's 0.5. So be very careful when you do your calculations. Next page. All right. Aquarium 1 contains 4.6 gallons of water. Louise began filling the aquarium at a rate of 1.2 per minute. So lots of information being given to me. Aquarium 2 contains 54.6, and we're going to be draining that aquarium 0.8 per minute. So it's asking after how many minutes will the aquariums contain the same amount of water. So when will aquarium 1 be equal to aquarium 2? Well, let's look and find out what do we know. We know for aquarium 1 it started with 4.6 gallons and we are filling or adding 1.2 per minute. And then that is going to be equal to aquarium 2, which started at 54.6 gallons, but we are draining, we're subtracting 0.8 gallons, again, per minute. So now I have my equation set up. I can go through and simply solve my problem. So I'm going to start by moving this negative 0.8x by adding 0.8x, so plus 0.8x. I'm going to make this a little bit smaller. That becomes 0.20x. So I'm just going to do 2x, 54.6, and then I'm going to try to get x by itself. So the only thing stopping me is that 4.6. So minus 4.6. Guys, I'm just going to bring this over to the side. I get 2x equals 50, and that can be divided to find out that x is 25. So x is 25, which means 25 minutes would be my answer. 25 minutes until they both have the same amount of water. Right. Which representation does not show y as a function of x? Now remember, the rule for functions, x cannot repeat. Hope y'all remember that. X cannot repeat. So what we're looking at is which of these is not a function, meaning which one of them does x repeat. If it's a graph, remember we use that VLT, that vertical line test. So let's look at A. On A, do any of our x's repeat? 1, 3, 5, 7. No, so that one is a function. B, I'm using the vertical line test. If I draw a vertical line on here, it only hits it one time, so B is a function. C, I have 2, 3, 7, and 11. So none of my x's repeat on that one, making C a function. However, on D, I notice that there are 2 lines coming off of that 3. We cannot have more than one line coming off of an x. Therefore, D does not represent a function. On the next one, find the rate of change demonstrated in the graph below. Remember rate of change, guys, this is simply the same as slope. Rate of change is simply slope. When we're finding slope on a graph, we use rise over run. Therefore, we're going up or down and running to the right. First things first, I need to find a couple of pretty points. I've got one here, I've got one here, so I'm going to use those. That means I'm going to rise up and run to the right. One of the most important things is to pay attention to what am I counting by. I am counting by 3, so that is up 3, 6, 9, up 9, and over 2. So I have a slope or a rate of change of 9 over 2, or 9/2. Flip your paper. So next we are looking to find out which of the following is true about the relationship in the table. So I see that it is asking, excuse me, about proportionality. Is it proportional or is it not? Now remember, a table is proportional, one, if it includes the 0.00, but that goes kind of far back, so I'm not sure I want to do it that way. I can also look and see, is there a constant rate of change? Like, does the change in x over the change, does the change in y over the change in x remain constant every time? So like the difference between 120 and 30, like that's a difference of 90, and 125, that's a difference of 75, right? So 90 over 75. And then I have 30 and 24, that's a difference of 6 over 5. So 6 over 5. Then over here, oh gosh, those have decimals, but 24 and 32. So 24 minus 13.2, 10.8 over 9. So I have 10.8 over 9. So my goal here is to find out, is it the same thing happening every time I enter these in? So like 90 divided by 75, I can simplify that, and that's going to become 6/5. then I already have 6/5. But what happens if I simplify 10.8 over 9? Well, honestly, guys, if you punch that in the calculator, you get 1.2. And watch what happens when I do math, enter, enter. It is 6/5. Therefore, I'm starting to see that this table is proportional. And it is proportional because I have a constant rate of change. What two whole consecutive numbers does the square root of 34 lie between on a number line? So I can go to my calculator, I can punch in the square root of 34, and I get 5.8. This is 5.8. Guys, what two whole numbers does 5.8 come between? Does it come between 4 and 5, 5 and 6, 6 and 7? Well, it's 5.8. So I can clearly see it comes between 5 and 6. I also know the square root of 25 is 5 and the square root of 36 is 6. Therefore, 34 comes between those numbers. So it's got to be somewhere between 5 and 6. Next, I have the square root of 181. I'm just going to highly encourage you guys use your calculators to get 13.7. So if I have 13.7, I know this number is going to lie between 13 and 14. All right, number 19. Write the equation and solve for x. Okay, so again, we just did these. This is when we have to know what kind of angles do we have here. Well, I know these are corresponding angles. They are the same size. They are congruent. Therefore, that makes them equal. So if I call this angle A and this angle B, then I know that angle A must equal angle B. That's going to help me solve my equation. So angle A is 3x minus 100. And I have to set that equal to angle B, which is x plus 50. Now, this should look exactly like what we've been doing. It's an equation with variables on both sides, and I simply need to solve for x. So I'm going to remove this x, remove the x, and again, if you have just an x, we can assume it is a 1 in front of it. Therefore, 3x minus 1x is 2x minus 100 equals 50. And then again, I'm going to add 100 to both sides. I'm going through this pretty quick because at this point, guys, you have been doing this long enough that you should know at this point what you are doing. So therefore, my last step is to divide by 2, and I get that x equals 75. Now, all it asked me to do was solve for 75. It didn't ask me to tell you the size of any of these, but if I plugged 75 back in for x, I would see that these angles are actually 125 degrees. Right, next we're going to determine the missing angle in the triangle. So right here, I see that we are looking for this missing angle. These are interior angles, and I know a triangle adds up to 180 degrees. Therefore, P plus Q plus R has to equal 180 degrees. Well, if P is X plus Q, which is 28, plus R, which is 67, if I add those together, I should get 180. Again, this is one of those easy ones, guys, because it's just X. You could simply add these two numbers together and subtract it from 180. I'm just going to show you how it would be done if you were actually doing it this way. 28 plus 67 gives me 95, so X plus 95 equals 180. And then you just subtract that 95 from that 180, and you get that X equals 85. All right, so we know that angle X, or angle P, is 85 degrees. What is the measurement of angle X? Now notice where angle X is located. Angle X is outside or on the exterior of this triangle. Remember, an exterior angle equals the sum of remote interior angles. Okay, so I'm just going to write that little note to help you remember. So that means that this is equal to the sum or the addition of the angles that are away from it but inside the triangle. So 80 and 60 in this case. So in this case, X equals 80 plus 60. So the exterior angle here is 140 degrees. All right, last question. Are the angles similar? Now remember, when angles are similar, they have to have at least 2 or more matching angles. Now I see we have at least one. We have 100 there, but we need to know, like, is this missing angle 35 or is this missing angle 45? Just let me know if I have another missing angle. Well, to do that, I'm going to use that interior angle, that law of interior angles, where I know interior angles add up to 180 degrees, so I need to see what's missing. I'm going to use triangle PQR. I'm going to add together 145, which is obviously 145. And then I'm going to take that away from 180 to get 35. So angle R is 35 degrees. At this point, do we have another matching angle? We do, 35 and 35. Therefore, triangle PQR is similar to triangle STU. So this is your fall semester exam review number 2. I hope you understand everything. If not, you're welcome to email me with questions and or talk to a friend and see if they can help you out, help you get through it. Good luck, guys.